next section, 2.6 2.7 2.8 are the same as I will assign them later. Okay, so 2.9 distance of a linear chord. So distance of a linear chord we already discussed either. No, what is the distance of a linear chord? A linear chord is a C, as a set of chord words. Okay, so any two chord words of distance എന്തായിരിക്കണം? What is distance? Distance means a number of disagreed positions. So any two and the least number ആയിരിക്കും. ഇപ്പം നമ്മളിപ്പോൾ chord words ഉണ്ടെങ്കിൽ ആ chord wordsന്റെ consider any two chord words, then a least distance ആയിരിക്കും എന്താണ് distance of a linear chord എന്ന് പറയുന്നത്. Okay, so that is the distance. Here we have a theorem, theorem 2.9.1. Let H be the parity check matrix. So parity check matrix ഒക്കെ already discuss ചെയ്യും. So parity check matrix means that H be is said to be a parity check matrix, which is the row. So parity check matrix means it is the column of a matrix H. Because H is said to be parity check matrix means a column of a H which form a basis for C perp. So C perp in the basis ആണ് column of the H ആണെങ്കിൽ then H is said to be parity check matrix. Okay, so H be the parity check matrix for a linear chord C, then C has distance D. C has distance D if and only if any set of D minus 1 rows of H is linearly independent and at least one set of D rows of H is linearly dependent. Okay, so the D is the distance of the linear chord. So when if and only if the distance of a linear chord is D, if and only if the rows of H, D minus 1 rows of H form a linearly independent set and D rows of H form a linearly dependent sets. Okay, so if the idea is that if V is a word, then VH is a linear combination of exactly WT of V rows of H. So if V is in C, WT of V is equal to D, then since VH is equal to 0, already നമ്മൾ parity check matrix already discussed ചെയ്യുന്ന കാര്യങ്ങളാണ് ഇതൊക്കെ. Okay, then since VH is equal to 0, some D rows of H are linearly dependent. If VH is equal to 0, then V is a chord word, so WT of V is greater than or equal to D. So this is the important, and here example 2.9.2 നോക്ക. So here C be the linear chord with the parity check matrix ആണ് ഇത്. Okay, അപ്പോൾ ഇവിടെ any two rows sum ചെയ്യുക. അപ്പോൾ first row is 1 1 0, add with 0 1 1 0 1 1, so we get what 1 0 1. Okay, and what we'll get, first row add ചെയ്യുമ്പോൾ 1 1 plus 1 0 0 plus 1 1, so we get 1 0 1, another 1 1 1 1 1 1, the 2 add ചെയ്യുമ്പോൾ 1 1 0, this 2 add ചെയ്യുമ്പോൾ 0 1 1. Okay, so any two rows of any add with the two rows add ചെയ്യുമ്പോൾ നമുക്ക് എന്ത് കിട്ടില്ല? It cannot be 0 0 0 0 നമുക്ക് മേക്ക് ചെയ്യാൻ പറ്റില്ല. So 0 0 കിട്ടുന്നില്ല. So 1 0 1 1 0 is add with 0 1 1, so we cannot get 0 0. Similarly 0 1 1 add with 1 0 0, so we cannot 0 0. So any two rows which doesn't give 0 0, then these two rows are linearly independent. അപ്പോൾ നമുക്ക് എന്ത് പറയാൻ പറ്റും? ലീനിയർലി ഇൻഡിപെൻഡൻ്റ് ആണെന്ന് പറയാൻ പറ്റും. ഹിയർ 2 റോസ് ആഡ് ചെയ്യുമ്പോൾ നമുക്ക് എന്ത് കിട്ടുന്നില്ല? 0 0 കിട്ടുന്നില്ല. സോ വിച്ച് മീൻസ് ദാറ്റ് this any 2 rows of this parity check matrix is linearly independent. Okay, and add 1 3 and 4. So 1 is 1 1, that is 1 1 0, 3 is 1 0 0, and 4th one is 0 1 0. So 1 plus 1 is 0, 1 plus 1 is 0 0. So we get these 2 rows add this rows, so we get 0 0. Okay, which means that 3 rows are linearly dependent. Clear? So here ഇവിടുത്തെ നമ്മൾ C എന്ന് പറഞ്ഞ ലീനിയർ കോഡിന്റെ ഡിസ്റ്റൻസ് പറഞ്ഞത് 3 ആണ്. ഓക്കെ, അപ്പോൾ നമുക്ക് എന്തായിട്ടുണ്ട്? Any 2 rows of H are linearly independent means, what is that? D minus 1 rows of H is linearly independent. So that is D minus 1 is equal to 2 ആണ്. So that means D is equal to 3 ആണ്. So we get a distance of a linear chord is what? 3. And what is that? D rows of H is linearly dependent. Here എന്താണ്? 3 rows. 3 rows ആഡ് ചെയ്യുമ്പോൾ നമുക്ക് 0 0 കിട്ടുന്നുണ്ട്. So any 3 rows of H is linearly dependent. That is D is equal to 3. So we get 3 is the distance of the linear chord. അപ്പോൾ ഇതാണ് distance of the linear chord ചെയ്യാനുള്ള method. Okay. So next, this is the distance, and next section is cosets. So cosets means what? Usually നമ്മൾ cosets ഇപ്പോൾ ഗ്രൂപ്പ് കേസ് കൺസിഡർ ചെയ്യുകയാണെങ്കിൽ G over H is a group ആണെങ്കിൽ what is its representation is what? A plus H or AH ആണ്, where A belongs to G ആണ്. So this is the coset mean, left cosets. Okay, left cosets. Similarly right cosets എന്ന് വരും H plus A യും H A യും വരും. So here a C is a linear chord of length n, and U is any word of length n. We define the cosets of C determinant by U to be the set of all words of the form V plus U, as V ranges over all the words in C. So we denote this coset by C plus U. Okay, but C is a what? C is a linear chord. Okay, C is a linear chord and U is any word of length n ആയിരിക്കണം. Okay, and C plus U is the form what? V plus U, such that V belongs to C. V is the chord word in C. So this is the C plus U is the cosets in cosets. Okay, this one is a form. So here C is equal to 0 0 1 1, and we take U is equal to 1 0 1. So C plus 0 1 1 0 1 is what? 0 0 plus 1 0 1, that is 1 0 1. 1 1 plus 1 0 1, that is 0 1 0. So this is the coset. And similarly U is taken as 1 1 1. So similarly we get 1 1 1 0 0, that is equal to C തന്നെയല്ലേ കിട്ടുന്നത്. And C plus 0 1 0 means that 0 0 add with 0 0 1 0 and 1 1 with 0 1 0. So we get 0 1 0 1 0 1, which is equal to C plus 1 0 1. Okay, but C plus 0 1 0 and C plus 1 0 was same ആണ്. So C plus 0 1 0 elements ഏതൊക്കെയാണ്? 1 0 1 0 1 0. Okay, അപ്പം നമ്മൾ എന്താണ് സെയിം സെറ്റിലുള്ള എലമെന്റ്സ് എപ്പോഴും എന്തായിരിക്കും? സെയിം കോസറ്റ്സിൽ തന്നെ ഉണ്ടാവും. ഇപ്പം U എന്ന് പറയുന്നത് 1 0 1 എടുത്താലും U എന്ന് പറയുന്നത് 0 1 0 എടുത്താലും രണ്ടിൻ്റെയും കോസറ്റ്സ് എന്തായിരിക്കും? ബോത്ത് ഓഫ് ദ കോസറ്റ്സ് ആർ സെയിം ആയിരിക്കും. Okay, and the next one if C is a linear chord of length n, then you might, okay, we have 2 raised to n different cosets കിട്ടും. Different cosets C plus U of C. So C is a linear chord of length n. We have 2 raised to n different cosets C plus U of C. One for each of the 2 raised to n different words U of the length n. Okay, If C plus U1 is identical with C plus U2, but U1 not equal to U2. But here, we consider U is taken as 101 and that is U1 is 101, U2 is 010. But C plus 101 is same as C plus 010. Okay. So, if U1 not equal to U2, their causes will be same. Okay. And here 2.10.3 is a theorem. We have 8 cases. Whole in the cases. Then the first one, what is first one? C is a linear chord of length n and U and V are the words of length n. First one is U is in the coset C plus V. Then C plus U is equal to C plus V. That is, each word in a coset determine that coset. If U is in the coset C plus V. But we will example consider C plus 101 element is 010. Okay. But so V is taken as 010. V is taken as 010 is in the coset C plus U. Clear? And what is C plus V? It's the same as C plus U. Okay. And the second one is the word U is in the coset C plus U. Here 101 is a word U and C plus 101 101. So U is a word in C plus U. Okay. And the third one is U plus V is in C. Then U and V are in the same coset. U plus V. So 101 plus 010. What will get? 101 is U and 010 is V. So 101 plus 010 what? 111, which is a word in C. So these causes are same. Clear? So U and V are in the same coset. Okay. And if U plus V is not in C, U and V are different coset. So 101 010. So what get this one? U plus V is not in C. U and V are in the different causes. And for fifth one is every word in Kn is contained in one and only one cosets of C, that is either C plus U is equal to C plus V or C plus U and C plus V have no words in common. Every word in Kn is contained in one and only one causes of C. Every word in Kn, one and only one causes of C contains that is in the C plus U is equal to the C plus V, which means that C plus U and C plus V have no words in common. C plus U is equal to only C plus U is fifth one is the same as 3 and 4. If U plus V is in C U, V are in the same coset. That is C plus U is equal to C plus V. Similarly, if U plus V is not in C, U and V are the different causes. That is C plus U is not equal to C plus V. Okay. So same as this one. If C plus U is equal to C plus V, either C plus U is equal to C plus V or C plus U and C plus V have no words. That is they are different. Okay. And the sixth one is modulus of C plus U is equal to modulus C. That is the number of words in causes of C is equal to the number of words in the chord. Number of words in the causes of C is the same as number of words. But here C is equal to 0, 0, 1, 1. So C plus 0, 1, 0, 1 have two words. C plus 0, 1 has 2 words. Same numbers. If C has dimension k, then there are exactly 2 raised to n minus k different causes of C, and each causes contain exactly 2 raised to k words now. And the eighth one is the chord C itself is one of its causes. Okay, C 1 1, C plus 1 1. C plus 1 1 is the same as C. Okay, but C in the chord C itself it is a causes. So this is another example. Just wait 5. Okay. And this is another and this one is an example. Just verify ചെയ്യാട്ടോ.